So in this video, I want to talk about the integration series of cosecant. And so up until the fourth power. And so what is the integral of cosecant of x dx? Well, again, just like secant, we're going to treat this as the integral of cosecant of x times cosecant of x plus cotangent of x dx on both sides. So this is my numerator. This becomes cosecant of x plus cotangent of x dx. Well, if I distribute, this now becomes the integral of cosecant squared of x plus cotangent of x dx over cosecant of x plus cotangent of x. Oh, cotangent of x. So yeah, so I forgot my cosecant. So this becomes cotangent of x, cosecant of x dx. So I apologize. Okay, and these are being divided. Okay. So what this allowed me to do is do u substitution. So if I set my u to be the bottom, which is cosecant of x plus cotangent of x, then my derivative now becomes, well, what's my derivative of cosecant of x? Well, that is negative cosecant of x, cotangent of x. So that comes negative cosecant of x, cotangent of x. Okay, what's my derivative of cotangent of x? Well, that is negative cosecant squared of x. Negative cosecant squared of x. Okay, so this becomes negative cosecant squared of x, which is exactly what we have. The signs are different. But notice I have a negative in common. So if I factor out my negative, this becomes cosecant of x, cotangent of x, plus cosecant squared of x. Okay. And this becomes dx. I forgot my dx here. Okay, and you can see I have a positive one. I don't have a negative one, and so in fact I could divide by a negative on either sides. Okay, and what this allows me to do is bring my negative over to my du, which gives me a positive cosecant of x, cotangent of x dx, which is exactly what we have. So rewrite an integral. This becomes negative du of 1 over u, because our u was this, and or du took care of this whole thing here, cotangent of x plus cosecant squared of x dx. Okay, and so when I do my integral is going to be given my negative natural log of the absolute value of u. In this case, what was my u? My u was cosecant of x plus cotangent of x dx. So it becomes cosecant of x plus cotangent of x plus c. So this is my integral for cosecant of x. So what is the integral of cosecant squared of x dx? Well, we already know this. This is just negative cotangent of x plus c. Okay. Now what about cosecant cube of x dx? Well, again, for this one, we got to use integration by parts. And so if I look at this, this becomes cosecant squared of x times cosecant of x dx. And all I'm doing is rewriting in such fashion that I can use integration by parts. And so when I look at this, well, I know my antiderivative of cosecant of x, cosecant squared of x. So if I set my f prime to be cosecant squared of x, then f of x, which is the antiderivative, will actually be negative cotangent of x. G of x in this case will be cosecant of x. Well, what's my derivative? That happens to be negative cosecant of x, cotangent of x. Okay, and so if we want to do integration by parts, if I look at this, my integral is going to be given by f of x times g of x. So this becomes negative cotangent of x times cosecant of x minus the integral of negative cotangent of x, which is f of x times g prime of x. Multiply that by negative cosecant of x, cotangent of x dx. Okay. So, well, what does this allow me to do? Well, if I look at this, I have 3 negatives here, 1, 2, 3. So that's an odd number of negative, which means that eventually I'm going to get a negative. So my integral is actually going to be given by a negative cotangent of x times cosecant of x. So integral is given by negative cotangent of x, cosecant of x, minus the integral I have two cotangents here, so this is cotangent squared of x multiplied by cosecant of x dx. Okay, well, for this one I have an identity very similar to secant. Okay, and so this integration is actually very similar to secant cube of x, and so my integral now is going to give given by negative cotangent of x times cosecant of x minus the integral of, this becomes, well, what's the identity? This becomes I'm having problems writing cosecant. So it becomes cosecant squared of x minus 1. I'm going to multiply that by cosecant of x dx, okay? And then you can see once I distribute, my integral is going to give given by negative cotangent of x cosecant of x minus the integral of cosecant cube now of x, because I'm distributing. Okay, so negative cosecant cube of x minus cosecant of x dx. Okay, and what eventually I'm just going to split these integrals up. So my integral now is going to give given by negative cotangent of x cosecant of x minus the integral of cosecant cube of x dx plus the integral, because this negative is being distributed to both, plus the integral of cosecant of x dx. Okay, and you can see here we have the integral, the original integral back, I, okay, which is essentially what we wanted to find. So if I add I on both sides, so this becomes 2i, and that is equal to negative cotangent of x cosecant of x plus the integral of cosecant of x dx. Okay, and remember we already did this. This is actually negative the natural log of cosecant of x plus cotangent of x plus c. So I'm just going to replace that with this. Okay, and so if I divide by 2 on both sides, well, my integral is now be given by 1/2 multiplied by negative cotangent of x cosecant of x. Trying to problems writing cosecant here. So this becomes negative cosecant of x minus natural log of the absolute value of cosecant of x plus cotangent of x plus c. Okay, and all I did was I have a minus sign, I have a plus sign here. The integral of this is actually negative natural log of cosecant of x plus cotangent of x. Well, a negative times a positive is always a negative, so that's why this becomes a negative. Okay, and so that will be my integral. Now let's look at the idea of cotangent of x, cotangent to the 4th of x. Okay, and so if I look at this, cosecant to the 4th of x dx. Okay, if I look at this, I'm going to split my integral up. So this becomes cosecant squared of x times cosecant squared of x. Well, that's the same thing as cosecant to the 4th of x. Okay, and so what can I do? I can use an identity. So this becomes the integral of cotangent squared of x plus 1. And we multiply that by cosecant squared of x dx. Okay, this becomes a simple idea now where I could distribute. So this becomes the integral of cotangent squared of x times cosecant squared of x, okay, dx. I'm just going to split it up all in once, plus the integral of cosecant squared of x dx. Okay, so now we're in a position like this, and essentially if I set my u now for this one to be cotangent of x, then I know my derivative is actually what? Negative cosecant squared of x dx. But again, we have a positive cosecant squared of x dx. So if we divide by a negative on both sides, so this becomes negative du, that is equal to cosecant squared of x dx. Okay, now we know this one. We know the integral of this one. This happens to be what? Negative cotangent of x. Okay, and so if I look at this, my integral now is going to be given by the negative du of, well, what was my u? Cotangent of x. Now it happens to be squared, so this becomes u squared. Okay, minus cotangent of x plus c. Okay, because the integral of cosecant of square of x is just negative cotangent of x plus c, and we have a positive here, so negative times a positive is always a negative. Okay, and so to clean this up, the integral is going to give me by negative 1/3. Well, what was my u? My u happens to be cotangent of x, so that becomes cotangent cube of x minus cotangent of x plus c. Okay, so you could see some staring with similarities between cosecant and secant themselves.